Hello everybody, welcome back. This is Frank Hunt. Continue your education on DC electric theory. Today I'm going to give you some introduction to Ohm's law, but I'm going to give you some place to go first if you'd like. I'm suggesting you go to the library because the books are free, but you can get any book that's called Basic Electricity, and they all start out with the same thing that I'm going to show you here today, the basic electricity. So let's say you're not ready to go do that right now and you can't find it on Google or whatever, but in 3 to 5 minutes, I'll give you a quick introduction. You ready for this? We had a drawing before of a battery showing a fuse and an ammeter and then a switch, and now I've changed all of those and the light bulbs, and I've changed these symbols of typical symbols that you find on a drawing that represent a battery. This is a symbol for a battery. So the voltage E, let me just restate what Ohm's law is. E equals I times R. That's the beginning for everything. And I was telling you the last time I was here that 2 times 4 equals 8, right? So you could place in the numbers and go like, well, okay, 8 equals 2 times 4. What if you didn't know that number? How would you find it? You'd probably do a little math and go like, oh, 8 divided by 4 is going to be 2. So you're going to just replace these letters with easy numbers, and then we're going to take the numbers that are exactly from our drawing to calculate what's going to happen in the current. Our whole goal is to figure out, before I turn the switch on, how much current is going to flow in this circuit. Can these resistors, can these things handle the current that we're going to flow? Excuse me, before I turn it on. So, let's say I had a resistor here of 2 ohms, and a resistor here of 6 ohms, a resistor here of 4 ohms, right? The current that's going to flow through this series circuit, and remember by definition a series circuit is that everything happens one event after the other. First the current goes through the fuse, then it goes to the ammeter, then it goes through the switch, then it goes through resistor number 1, that's 2 ohms, right? That's the symbol for ohms. Resistor number 2, that's 6 ohms. Resistor number 3, that's 4 ohms, right? So we would add this resistance to the flow up when it's in a series circuit. So now our resistance is going to be, go back to our formula for a minute. If we don't know the current, we're going to go like I equals what? 8 over 4, right? So 8, which is the E, over 4, which is the R. And our E is our voltage. Let's say we have a 12 volt battery. So that's 12 volts. And our R is all of the resistance along this path. 2 plus 6. That's 8 plus 4. That's 12 ohms of resistance along this series path. So 12 ohms, 12 volts equals 1 amp. Simple math. So 1 amp is going to flow through this fuse. 1 amp is going to flow through this ammeter. Right? We're going to be measuring 1 amp. 1 amp through that switch, 1 amp through this resistor, 1 amp through this resistor, 1 amp through this resistor. All the way through, there's 1 amp flowing along this battery's alive. So that's the simple part of series circuit. Ohm's law. I is the current. The current, remember, is the quantity of electrons, you might say, that are going to flow through. And measured in amps. E equals I times R. As the voltage might deteriorate, we were talking about the battery getting old and not putting out 12 volts anymore, that would change how much current is going to flow. Let's say this battery all of a sudden was only putting out 6 volts because it's been on all night. Now all of a sudden this weak battery is only putting out 6 volts, right? Now the 6 volts is going to go through this resistance, so our voltage here in our formula would have to change to 6. Our resistance is still built in at the factory. This resistance is not going to change. It's 12 ohms, so now our current flow is only going to be what? 0.5 or a half of an amp, right? So when we reduce our voltage, we reduce how much our current is. If this is the light bulb, right, and we have only a half of an amp flowing through here instead of 1 amp, it's going to produce less and less light with less current flowing through it. That makes sense? And if this battery were a solar system, suppose this were our solar panel here, and now all of a sudden it's a cloudy day and we're not putting out 12 volts, now we're only putting out 6 volts, we're going to put out less light at this resistor. Make sense? Okay, I'll be back to you next time with parallel circuits.